Hello and welcome back to another video. Here we're going to be looking at inverse functions. So this is the third and final video on functions. So pause the video if you need to, grab a pen and let's get started. So the objective here is to find an expression for the inverse of a particular function. So before we get started, let's have a quick definition. So the inverse function undoes the original function. So if we have a value, if we have a function f of x, which is 2x plus 1, then the function gives the input that generated a particular output. So if we know what the output is, we might want to know the input that gave us that output. So that's what the inverse function does. So here's an example. It says, given that f of x is 3x take away 5, find the inverse function. So find f to the minus 1 of x. So if the function f of x takes a value of x, multiplies it by 3 and subtracts 5, then the inverse function is always going to do the opposite. So it's going to take a value, it's going to add 5, and then it's going to divide it by 3, because that's the opposite of taking a value, multiplying it by 3 and subtracting 5. So we're going to call this function the inverse function. So this is the answer to this question. Another way of doing this question is we replace f of x with y, because f of x is another way of labelling the output, and the output is often denoted as y. So we call y equal to 3x minus 5, so we replace f of x with y. And then we try and make x a subject. So the reason why we're trying to make x a subject is because we want an expression for the input that generated the output. So if we do that, we're going to add 5 to both sides. So we have y plus 5 equals 3x. And then we're going to divide both sides by 3. So x equals y plus 5 divided by 3. And that is the inverse. So the final step is to just replace the y with x and write the inverse function using this notation. So we have f to the minus 1 of x is x plus 5 over 3. So that is the answer to that question. So here's another example. So it says, given that f of x is x plus 2 over 5, find the inverse. So again, this function takes an input, adds 2, and then divides the whole thing by 5. So the inverse is going to do the opposite. So it's going to take an input, it's going to multiply it by 5, and then it's going to subtract 2, and that's going to be the output. But if we do it properly, if we first start by replacing f of x with y, so we have y equals x plus 2 over 5, and then make x the subject. So first we need to multiply both sides by 5. So we end up with 5y equals x plus 2. And then subtract 2 from both sides, we get x equals 5y minus 2. So the answer, f to the minus 1 of x, is 5x, because we now replace y with x, take away 2, and that is the answer to that question. Here's another example. So given that f of x is 1 plus x over 2, find the inverse. So this function takes a value, divides it by 2, and then adds 1 to the result. So the opposite is going to be minusing 1 from the result and then timesing the whole thing by 2. So again, we're going to do this. We're going to write f of x as y. So y equals 1 plus x over 2. And then we're going to subtract 1 from both sides. So y take away 1 equals x over 2. And then we're going to multiply everything by 2. So we have x equals 2 bracket y minus 1. So then we can write the answer, f to the minus 1 of x, as 2 bracket, and we can replace y with x now. So it's going to be x minus 1. And then if you expand the brackets, which you don't have to, but it's a nice touch, you end up with 2x minus 2. And that is the answer to this question. Here's another example. So we're going to replace f of x with y first. So y equals minus 6x plus 1. And then we're going to make x the subject. So to make x the subject this time, we could start off by adding 6x to both sides. So we end up with y plus 6x equals 1. And then if we minus y from both sides, we get 6x equals 1 minus y. And then dividing both sides by 6, we end up with x equals 1 minus y divided by 6. So the answer to this question, so f to the minus 1x this time, is going to be 1 minus x, because we then replace y with x over 6. And that's the answer. Here's another example. So we now need to find the inverse. So again, we're going to replace f of x with y. So y equals 2 bracket x minus 3 squared plus 1. And now we're going to make x the subject. So the thing that's in the way of x being by itself this time is the plus 1, the 2, and the squared. So to get rid of the plus 1, we're going to minus 1. So y minus 1 equals 2 bracket x minus 3 squared. Then we're going to divide everything by 2. So y minus 1 over 2 equals x minus 3 squared. square root both sides, so we end up with x minus 3 equals the square root of y minus 1 over 2. And then adding 3 to both sides, we end up with x equals 3 plus the square root of y minus 1 over 2. So the answer to this question, f to the minus 1 of x equals 3 plus the square root of x minus 1 over 2. And that is the answer. Here's an exam style question. So it says, given that f of x is 3x minus 4 over 2, firstly, we need to find the inverse, and then we need to hence solve f to the minus 1 of x equals 7. So if you want to have a go at this question, pause the video and I'll go over it in a moment. Okay, so welcome back if you had a go at that. So firstly, we need to find the inverse. So we're going to replace f of x with y. So we have y equals 3x minus 4 over 2. And then we're going to try and make x the subject. So firstly, we need to multiply both sides by 2. And we end up with 2y equals 3x minus 4. Then we add 4 to both sides. So 2y plus 4 equals 3x. And then dividing everything by 3, we end up with x equals 2y plus 4 over 3. So the inverse is going to be 2x plus 4 divided by 3.